Everyone, it's February 21st. Today was better than yesterday. Not as frustrating. Finally, I got the tool that I want to write. Made great progress. Great progress today. And basically, the base functionality is done. So the rest will just be a few more features I want to add, plus maybe a little bit. Cosmetics. I might add some cosmetics, like color, some color to the. Wait, what the hell is this problem? Oh, we're not supposed to keep doing on this one. We're supposed to do this one. Oh my goodness, I was completely. I was completely confused. Anyway. Yeah, so yeah, just some cosmetics and one more feature to add, and then we're good to go on this one. Yeah, that was this is some learning. Yeah, some learning, some on the TypeScript, some on the ServiceNow itself. Overall, it's pretty good. It's pretty good. Yeah, I'm happy that I can get this one to work. Even without the automatic stuff, I probably can just run a command to download it. Yeah. Anyway, let's take a look. Bitwise AND of numbers range. Given two integers left and right that represent the range left to right, return the bitwise AND of all numbers in this range, inclusive. Bitwise AND of everything in this range. Well, it's going to be 0. Most likely, it's going to be 0. So all we need to do is to check if any position is 0, right? As long as one position is not 0. Or what we shall check is at each position, we need to check if there's going to be a 1 in that position. No, if there is going to be all 1s in that position. How do you check if it's going to be a 1 in that position? That's a good question. Yeah, we do bitwise AND. Well, first of all, if we have some value, if the left and right, yeah, that's not right. So I think it's if you go through a cycle, then you will always have, right? Okay, it's 1, 2, 3. If you do this, it's gonna be 0. But if you do these two, then it's not gonna be 0. I'm just trying to see 4, right? And 5, 6, 7. Yeah, 5, 6, 7 is not, because we have this. And 8. We have 8, this is gonna be 0. So yeah, of course, if it includes a power of 2 and I have all the zeros, I don't think that's how it's supposed to do though. But anyway, we have the smallest, right? Now we have the biggest. The biggest thing have whatever the smallest. It depends on the smallest, okay? Because the smallest will have all the zeros. So what we need to find out is the left, right? The right actually doesn't really matter that much. So it's just the left, because they have all the zeros, which means all of the things to the left don't have to consider. So we just need to consider the small one, right? The small one. And for the small one, and we have a certain number of digits, right? Certain number of digits. So we have a small, which is the left, right? We have 1 and something, right? So we're gonna have to keep check to see if I get to this, right? Which basically just mean we have the total number of digits and then 1 left shift this, and then see if this is within. If this is within, if this is smaller or equal to right, then it's going to be 0. No question. It's just going to be 0. If not, then at least we have this 1, right? At least we have this 1. And we're going to have the last one is going to be all 1s, right? And then what? Then we have to figure out in this part, right? We're going to figure out this part. In this part, depending on what this one is, right? If this one is 0, so what we're going to do is try to find the first one, right? So now we're, because everything else doesn't matter, so we need to do, we start from this 1. But then we need to see if 1, 0, 0, 0, if this one is involved, right? If this one is involved, I think it will always be involved. Because no matter what, right? No matter what, I have this 1 and I have a bunch of stuff, right? And then if you say the large is smaller than this, then we have 1. We'll definitely have 1, 1, 1, 1 in this, right? So if we consider this part, we might have some leading zeros. Then we have a 1. Or we can have a 1 right here, right? We can have a 1 right here. And we have this 1, and then, oh, if I have this 1, then this will always be 1. But once I start having a 0, because of this, I have a 1. This is all 1. So once I have a 0, then we have this part. And this part, like I start from a 1, it must go through the entire process, right? Because it goes basically from, it has to go to, because it goes all the way to 1, 1, 1, 1, 1, right? So basically this 0 will have to go to a 1, 0, 0, 0. So, okay, so what we need to find is the smallest left, okay? Smallest left. Find it's this. If this is smaller or equal to right, then we return 0. If right is smaller than this, then what we do is just walk through this thing to find how many 1s do we have. Whatever 1s do we have, then the answer will be just these. Okay, so let's try it. Okay. So I have the left. How do I quickly compute? So I have a left, right? How do I know the number of digits on the left? as a binary? Well, I think what I can do is I can do left shift 1. Okay. If the left, we can left shift 1, and then we can, yeah, I don't think, like, how are you going to I mean, we can do right shift, right? Right shift can give me the number of digits, because if I shift to 1, 2, 3, 4, yeah, that can give me the digit. Then all I need to do is, yeah, if I do a right shift, this one will cause, right? If I do a right shift, well, shift 1, shift 2, so I know there's 2. Then I do 1 shift 1 shift 2. That will be the, okay. So I can do a right shift. Int l equal to left, while l is larger than 0. All right. L right shift 1. Oh, I need count. Right, and then int num digit equals 0. L num digit plus plus, and L right shift 1. So now I have number of digit. Then I say if one left shift number of digit is smaller or equal to right, then I'll return 0 immediately, because one left shift is gonna be 0. Otherwise, that just count how many ones is on the left hand side. How many ones is on the left hand side? So how do I count the number of ones on the, well, I can turn it into, oh, I don't want to turn it into anything, right? But how do you get it then? The last consecutive count. I can do that. Consecutive count. Consecutive ones. And every time I hit a 0, we'll reset. Okay. So number of digits, consecutive bit count. Okay. So we do this, and then say if L2 is equal to 1. Okay, then we say consec count plus plus, else consec count equal to 0. Streak is broken. So it's 1, I keep adding, and then eventually what I will get is the, so okay, so now we have the number of consecutive count, and I have the total number of the bits, right? We know the number of bits. Let's call it number of bits. Num bits. Okay, so we call num bits. Now what we need to do is to go. Oof. Hold a sec. What we need to do is I know the consecutive counts. I know that. So I can just return one left shift, right? One left shift consecutive bit count. If it's 3, I left shift 3. And then the whole thing -1. Okay, so that's kind of my solution. Let's see if you're right. It was not right. The first one is not right. The first one I say it's. Oh yeah, that's not right. It's just okay, so yeah, that's not right. That is not right. It's going to be like 1 1 and then the rest will be 0, right? The rest will be 0. I know the total count. I know this. So I have to, yeah, this is not right. But we can fix this. So 1 left shift this, 1 left shift this, 1 left shift this, right? So I can say int res equal to 0. I just wonder, right? Will there be an easier? Oh yes. We do this. Okay. Yes, we do this. Right, and then left shift the total number of bits minus consecutive bits, right? So if I have 3 bit, a total of 5 bits, so I just do 2. Okay, let's try this. Okay. Alright, so this is kind of my idea. Let's see if this idea is right. So for the left, right, we have the total number of bits. If 1 0 0 0 with 1 more bit than left is within the range, then the result is 0. Okay. Otherwise, we only need to count then we only need to keep, right, the consecutive ones on the most significant bits of left. Or call this 01. Alright, so just throw some number in there. Okay, let's give this a shot. if it's right. It's not right. Oh. Edge case. Huh. Interesting. 5. Yep, that is true. Maybe we really should do yeah, we should willing to keep the consecutive ones, the most, then we recursion, and we do recursion on the remaining, right? That was the idea. We do recursion on the remaining. So this is int res equal to this, and then we need the recursion. Now the recursion is this res exclusive or, actually exclusive or left and exclusive or right, right? Exclusive or left and exclusive or right, and we do range bitwise AND of those, right? And then eventually you will get to a position, like in this case, if I exclusive all left and right, and we'll get still the same value, right? The same value. So if they're the same value, what do I do? It's the same value, so I start from here, then we'll get to then we will get to a 0, right? We'll get to a 0, so I think it should be fine. Maybe we should say return res or range bitwise left exclusive or res, and a right exclusive or res. Oh, because I didn't have the end. Okay, if what about 0? Right, so it should say if right is equal to 0, return 0. Okay, let's try this one. Oh, all the edge cases. What is this? I think this is all ones. This is all 1 with a 0. Yeah, it should be, but what happened? I got all that, right? I got all the ones because I have, because I did this. Oh, because I overflowed. Yeah, it overflowed. My goodness, it overflowed. Oof. So can I long this maybe? What if I do long on this? Would that work on this? Oh. Hold on. Maybe we do this long. Actually, I don't know how. That's very interesting. Okay, hold on. That is very interesting. We shall do a J shell. So one left shift. 31. There's no way, right? It just give you a negative value. And even if you say long 1 left shift 31. How about this one? Oh, long 1. I put the parentheses wrong. Long 1. Yeah, hold on. What is this? Oh yeah, I'm missing a parentheses. Okay, so we have a long, so I can prevent this from happening. And these are definitely, oh, that can be, oh my goodness. So to prevent this from happening, I will do long for all of them. Every time we do a left shift, we'll do long. Right? Every time we do a left shift. So, yeah. Oh my god. Lossy conversion from possibly a lossy conversion from long to int. Oh. So maybe we do a long and then we return an int. Oh my god. Now the answer is int, so this will be int. And I just int this whole thing. Then I don't have to worry about here. Right, so inside here, because it's a left shift, we might need to be long, so everything is long. But then I'll do int, because I know the result is will be int. It won't be bigger than this, right? So pay attention, right? Just be careful. Be careful about the overflowing conditions, situations. That's the thing. You have overflow. Right? We don't like overflow, but there's no out of the way. This is Java. Java, you have overflow. Yeah, some people just think, you know, when you use like Python, you get really simple, and because it's simple, that you are not as worthy a programmer. I never think this way. I think you're always worthy of, I mean, the overflow things is just like really tiny part that I think should be automated, right? We shouldn't care or worry about that. Oh, you just, I think they just return left. If bin is not, yeah, that's true. Otherwise, one left shift this, and then it will be one and lame. Yep. That's the same idea. I used a little bit more trick to do it, and I'm not sure. Maybe Java has a better way to do this, but yeah, in Python it's gonna be very simple. Okay, so that's that. I just want to take a look at this one. Just stumbled yesterday to see if I can still figure out how to do this. Given a string, partition it into one or more substrings such that the characters in each substring are unique. That is, no letter appears in a single substring more than once. And the minimal number of substrings in such a partition. Aren't we doing this with a sliding window? We just go from left, just keep going, right? Return the minimal number of substrings in such a partition. Actually, I was going to say we're going to try to get as big as possible, right? If I get as big as possible and then I go as big as possible for the next one. So is greedy going to work? Like, why would it work? Can you prove it? So to prove it, I say if we don't do greedy and I just prematurely stop and I say I can get the best, right? Okay, so I have this premature stop and I have this and this, right? We set it up. And then if it's premature stop and I have more that I can group here, then I can always extend, right? It won't make it worse because without those, they will still be with unique. So yeah, I think sliding window. I will use sliding window for this with greedy. Yeah, exactly. So I'm not doing this because I know the solution. It'll be easy to program. All right, insert greatest common divisors in linked list. Given the head of a linked list head in which each node contains an integer value, between every pair of adjacent nodes, insert a new node with a value equal to the greatest common divisor of them. Return the linked list after insertion. The greatest common divisor of two numbers is GCDS. So given a head, I have a head. Between every pair, insert a new. So like 18 and 6, we insert 6. 6 and 10, we insert 2. 10 and 3, insert 1. Okay, so... Okay, I can smell some recursion happening. Basically, I just need to know. Yeah, I think it's a recursion problem. Shall be able to do this very fast. And we're gonna stick to Python for this one because we need practice in Python. Oh, holy crap, this is not right. We need a Python version 7. Yeah, I have something in NeoVim right now I need to improve. Oh, what the hell is this? Yeah, what I need is I mean it's simple. I think there is a solution for that. What I need is for the buffer to remember what I have. Like when I close everything and I open everything, I wanted to open the exact same stuff, right? So that's something I want to improve. But anyway, so for this one, I basically say if not head.next, just return return head, right? Return head. If not head.next, return head. Otherwise, I have the next, so I just insert one in between. Then we say next will equal to head.next. Yeah, I need to put it out. And then I say head.next equal to list node. Val is going to be, does it have GCD directly? Yeah, math GCD. Head.val and head.next.val. Okay, and then next should equal to head.next. I don't even need this. I do need this. So I do val equal to this, and this is going to be next, right? So head.next is the new one. Then actually no. All right. Actually no, I don't like this. I can do this self.insert head.next. All right, what do you think about this? If not head, return head. Otherwise, head.next equal to this, then we return head. Or I can just say if, right, I don't do this, I do this. Right, if head.next, head.next equals a new node with the next is this. Otherwise, return this. Okay. Oh, sorry, just a habit. I did a lot of JavaScript and stuff today, and then it's understandable. All right, let's see. Is it correct? Yeah. So recursion is the way. Recursion is the way to go. It's like a tail recursion, so it'll be go like ON, I think. I think it'll be fine. Good problem. I actually like it. Okay. Check. Easy to understand. Recursion. Return head. Oh, they're moving forward. Yeah, it can move forward. It can move forward. I just like to use recursion for this. I think it's more fun. Use recursion. All right, move on. I'm not gonna move on. I'll stop right here and then call it a day. Good. We did well. All right, I'll see you guys tomorrow. Adios.